I am using break time 200 milliseconds scikit-learn. Break time 200 milliseconds, a popular machine learning library in Python. Break time 200 milliseconds, and specifically its Gaussian process regression model with a DotProduct kernel. Google style name excited. It's a powerful tool for regression tasks. Google style break time 200 milliseconds. This kernel uses the DotProduct to measure similarity between data points. This section introduces the core problem. We're given two data points and asked to analyze the DotProduct kernel's output for those points. Well, calculate and interpret that result. We have two data points x1, which is the vector 1, 2, and x2, which is the vector 3, 4. These will be the input to our kernel calculation. This is our first data point. It's a vector represented as a list of numbers. In this case, the values are 1 and 2. This is our second data point, similarly represented as a vector 3, 4. This tells us that we're about to compute the dot product of x1 and x2. This is the core calculation for this problem. This is true by definition. The dot product kernel directly calculates the inner product, also known as the dot product of A input vectors, providing a measure of their similarity. This statement is correct. I calculated the dot product 1, 3, 2, 4, 1, 1. This is exactly what we are given in the question. This is absolutely correct. A larger dot product implies greater similarity between the vectors. Think of it as how much the vectors point in the same direction. I am calculating the dot product of vectors x1 and x2, 1, 3, 2, 4, 1, 1. This shows statement A is true. I am explaining why this is false. The dot product can be negative. For example, if x1 1, minus 2 and x2 minus 3, 1, then the dot product is 1, 3, 2, 1, 5, which is negative. So, statement D is incorrect. The Google style name emphasis dot product Google style kernel, as its name suggests, directly calculates the inner product dot product. Therefore, statement C is Google style name emphasis definitely Google style true. A larger dot product means the vectors point in a more similar direction, indicating higher similarity. Therefore, statement B is true. I am calculating the dot product, a way to measure how similar two vectors are. It's like seeing how much they point in the same direction. Break time 300 ms. Think of it as a measure of agreement between the two sets of numbers. Break time 300 milliseconds. Google style name lively. It's fundamental to understanding the dot product kernel. Google style. I am evaluating which statements accurately describe what the dot product kernel does with the given data. I am determining which statements align with the computed dot product and its inherent meaning within kernel methods. Break time 300 milliseconds. Google style name friendly. Let's see which options correctly interpret our result. Google style. This statement claims that the kernel's output for the given data points equals 11. To verify this, I compute the dot product of x1 1, 2 and x2 3, 4, 1 3, 2 4, 1 1. Therefore, the statement is true. Break time 200 milliseconds. Google style name enthusiastic. This is the direct result of the calculation. Google style. This statement says that the result of the dot product shows how similar the two input vectors are. A higher dot product means more similarity. This is true for the dot product kernel. It's a similarity metric. Break time 300 milliseconds. Google style name friendly. It's a key characteristic of the dot product kernel. Google style. This statement is true by definition. The dot product kernel, as its name suggests, specifically calculates the inner product dot product of its input vectors, break time 200 milliseconds. Google style name excited. It's the very definition of the kernel. Google style. This statement claims the output will always be positive. However, this is false. The dot product can be negative if the vector's components have opposite signs. For example, consider x11 minus 2 and x2 minus 3. 1. Their dot product is 1, 3, 2, 1, 5 negative. Break time 300 ms. Google style name serious. It's important to be aware of the possibilities. Google style. I am presenting a problem about using scikit-learn's Gaussian process regression with the dot product kernel. We have two data points, x11, 2 and x23, 4. The goal is to determine what's true about the kernel's output, kx1, x2, for this dot product kernel, assuming no extra scaling or adjustments. Break time 500 milliseconds. This statement is Google style name excited. True. Google style. Break time 300 milliseconds. The dot product kernel calculates how similar x1 and x2 are. A higher number means they're more alike. Absolutely. Google style name excited. True. Google style. Break time 300 milliseconds. The dot product kernel's job is to compute the inner product, a fancy name for the dot product of the input vectors, which is exactly what we are doing here. This is Google style name excited. True. Google style. Break time 300 milliseconds. I calculated the dot product 1 times 3 plus 2 times 4, which equals 11. That's the value kx1, x2. This statement is Google style name emphatic false. Google style. Break time 300 milliseconds. The dot product can be negative if the vectors have components with opposing signs. Break time 300 milliseconds. For instance, if x1 were 1, minus 2 and x2 were minus 3, 1, then kx1, x2 would be minus 1. We're given two data points for context. x1 is the vector 1, 2 and x2 is 3, 4. I calculated the dot product of x1 and x2. I did this by multiplying corresponding elements and adding the results 1, 3, 2, 4, 1, 1. I am analyzing a problem about scikit-learn's Gaussian process regression using the dot product kernel. We have two data points, x11, 2 and x23, 4. The goal is to determine which statements are true about the kernel's output, kx1, x2, which represents the kernel function's result when applied to x1 and x2. Break time 300 milliseconds. This is all about understanding how this specific kernel measures the similarity between data points. Break time 300 milliseconds. This statement is true. Google style name friendly. The dot product kernel calculates the similarity Google style break time 100 milliseconds between two vectors by computing their dot product. A larger dot product indicates a higher degree of similarity. It's like asking how much the two vectors point in the same direction. Break time 300 milliseconds. This is also true. Google style name excited. The dot product kernel, by definition, computes the inner product dot product of the input vectors. Google style break time 200 milliseconds. The inner product is a mathematical operation that measures the similarity between two vectors. For the vectors x1 and x2, this is 1324. Break time 300 milliseconds. This statement is correct. I found this by calculating the dot product of x1 and x2, 1, 3, 2, 4, 1, 1. Google style name confident. This is the direct result of applying the dot product kernel to our specific data points. Google style break time 300 milliseconds. I found this statement to be false. The dot product can be negative if the vectors have components with opposite signs. For example, if x1 were 1, -2 and x2 were -3, 1, then kx1, x2 would be 1, 3, 2, 1, 5. A negative value. We're using a say-is interpret as characters Gaussian process regression say-is model. A powerful tool for making predictions. With a specific type of kernel called a say-is interpret as characters DotProduct say-is kernel. Think of the kernel as a function that measures how similar two data points are. The DotProduct kernel does this using a simple calculation. As you'll see, break time 300 milliseconds. Here's our challenge. I have two data points, x1 and x2. Each point has two values. The problem asks you to find kx1, x2, which represents the output of the DotProduct kernel when I use these 2 points as input. The DotProduct kernel will calculate the similarity between these points. Break time 300 milliseconds. This statement says that the result of applying the DotProduct kernel to x1 and x2 is 11. Well, verify this by calculating the DotProduct. Break time 300 milliseconds. This statement claims that the result of the DotProduct kernel gives a measure of how similar x1 and x2 are. That is the core idea of kernel methods, to quantify similarity. Break time 300 milliseconds. This states that the output of the kernel is the say as interpret as characters inner product say as, which is the same as the dot product of x1 and x2. Let's confirm this is how the dot product kernel works. Break time 300 milliseconds. This statement says that the result of the dot product kernel is always a positive number. We will determine whether this is always true or not. Break time 300 milliseconds. This section guides you to actually calculate the dot product. The dot product of 1, 2 and 3, 4 is 13. 2, 4, 3, 8, 1, 1. Break time 300 milliseconds. This is the actual calculation. Multiply corresponding entries of the vectors and sum the results. This directly answers part A. Break time 300 milliseconds. I calculate the dot product of vectors x1 and x2 like this. I multiply the corresponding elements of x1 and x2. And then I add up those products. Specifically, 1 times 3 plus 2 times 4 equals 11. This is the result of the dot product kernel calculation for these two vectors. This line shows the calculation. I am using the notation kx1, x2 to represent the kernel output, which is simply the dot product of x1 and x2. I already explained the calculation in the previous row. And here, I get the final answer, 11. This statement is true because, as I just showed you, the dot product of x1 and x2 is, indeed, 11. The dot product is a measure of similarity, although not a normalized one. A larger value indicates more similarity between the two vectors. Think of it like this: the more aligned the vectors are, the larger the dot product will be. This is true by definition. The dot product kernel in sklearn is the inner product dot product of the input vectors. That's what makes it so straightforward to calculate. This is false. The dot product can be negative if the vectors have components with opposite signs. For instance, if x1 was 1, -2 and x2 was -3, 1, then the dot product would be -1, which is negative. These are the two data points we are working with: x1 1, 2 and x2 3, 4. They are two-dimensional vectors. And we are applying the dot product kernel to them. Here is the main question of this problem. We are given two vectors and need to find their dot product using the dot product kernel, which, as we discussed, gives us their inner product. We are using a Gaussian process regression model with a specific type of kernel function called a DotProduct kernel. This kernel function computes a similarity measure between vectors. And that measure is simply their inner product. Google style name enthusiastic. It's a very common and useful method. Google style break time 300 milliseconds.